Welcome to chapter 5. So we're going to be talking about a few things in this chapter, but we're going to start with biomes and let's see, terrestrial biomes. We're also going to go into aquatic biomes and how vertical stratification distinguishes between various biomes. So let's get started, okay? Actually, I want to challenge myself. Here's this, what are the 9 major terrestrial biomes? So if you look biomes up in good resources, you'll find out that it's kind of a subjective measurement, if you will. So, you know, some authors have 7 biomes, have some 9, some have 12. I find it amusing that there's no like textbook answer where everybody goes, no, this is what it should be. But there really isn't. So we're going to go with what Cunningham says, and by golly, it said 9. So I'm going to count them off. We're going to have 9. Here goes nothing. Okay, so first of all, what's a biome? Okay, well, terrestrial means that it's going to be on soil, on land, okay? And that's what we call a large biological community, is a biome. The problem, if you will, is that not all biological communities are the same, and what's found in that biological community is frequently dictated by, among other things, temperature and precipitation. So it is common to confuse temperature and precipitation as the definition of a biome, but it really isn't, okay? Really, we're looking at the biological community, what is living there. Temperature and precipitation will, to a large degree, dictate what is found there biologically, so we can't ignore it, and that's how we're going to use it. But keep in mind, we're looking at life. We're not looking at just those 2 traits, okay? An important characteristic of each biome is its biodiversity. In other words, how diverse that biome is. Right? So variety and of the different species that live in a particular area. So this is the author's synopsis of the different biomes, and you can see here's temperature and here's precipitation. So going with the hottest and wettest, we start at tropical rainforest, and then as the precipitation decreases, we go into tropical seasonal forest, tropical thorn, scrub, and woodland, and then at the very bottom, where we have very little or very low precipitation, we end up with desert. Okay, in the middle range. So this is why I like this. I really like this diagram, because you know, some of the definitions, they'll say moderate temperatures. Well, shoot, every time that they describe a biome, this is a moderate temperature there, and there's a moderate temperature over there, and there's a, and over here, it looks really well defined. Here's your moderate temperatures right here. You can be blind and figure it out. So moderate temperatures, okay? We're looking at temperate rainforest, temperate forest, savanna, and some grasslands, and some desert. That made it easy. At hot temperatures, rainforest, tropical seasonal forest, tropical thorn scrub, desert. Okay, and we can also do it by precipitation if we wanted to. If we want colder area, we're talking about boreal forest, and the coldest biome of all is the tundra, right? And it's interesting to note, you know, I don't know about you guys, but I'm always interested to see where we fit in the world, right? Here we are. Here's the Pacific Northwest, okay? And you can, hopefully you can see the pink there. So that means that we have some temperate rainforest, okay? Not tropical rainforest, temperate rainforest. So that would be this guy right here, temperate rainforest, okay, right there. And we have some temperate conifer forest, very, very cool. And we have some temperate grasslands and savannas as we move to California. And then we have, well, desert and scrublands as we move up to high desert. Okay, and if you can't see, you can always make it bigger. See if I can move it. So there's our pink, our green, our brown, and our yellow, right? What else can we see? Well, that's the Pacific Northwest. What about right down the middle? Temperate grasslands and savannas. Not a surprise. This is the breadbasket of the United States and Canada, right here. Okay. And then over here we have temperate broadleaf and mixed forests. Again, not a surprise. Remember, if we think of New England and those beautiful deciduous trees, those maples and all those beautiful trees, we're thinking about this area right here. Okay. And then temperate conifer forests as we move into the Florida Panhandle. And oh, that was exciting. Okay, there we go. And then, if you look on there, we have green and we have dark green. So, tropical and subtropical seasonal forest, and believe it or not, tropical rainforest. So yes, the very tip of Florida is considered a tropical rainforest. And all you have to do is go there and you will believe it. Okay. Up here, we have the boreal forest. And then above that, we have tundra. Greenland being rock and ice, beautiful. Look at Brazil. Tropical rainforest. This is where the world is trying to keep us from dying. As the tropical rainforest tries to fix carbon dioxide and release oxygen. That's happening right here and here and here in Central Africa and in the Southeast Asia. Look at Southeast Asia. See how nice and dark that is? Here's Japan, that doesn't qualify. Guinea. Okay. Then over here we have boreal forests again. You know, I don't know, what can I tell you? We are blessed with this beautiful area right here. Over here, there's a lot of cold, a lot of mountains, not a lot of nice flat areas, so we're very blessed in the Americas. Okay. Vertical zonation, what does this mean? Okay. I can imagine where this came from, and it has to do with because I've tried covering biomes before, and inevitably, right in the middle of the lecture, somebody raises their hands and they're like, "That sounds like Northern California. That sounds like Idaho. That sounds like yes, it does. Yes, it does. You don't have to go very far in order to enter a different biome. So I imagine that Cunningham and Cunningham have gotten beaten up by students the same way I have, and they're like, look, let's cut to the chase. You can literally find a place in the United States where, what happens? If you were to walk 100 kilometers, you would enter 1, 2, 3, 4, 5, 6, 7 different biomes. essentially from Fresno to Mount Whitney. Okay, so stop telling us that you're entering a different biome in a different state. That is no longer a surprise. I can just imagine. It's no longer a surprise. Watch, we can find all of them in 100 kilometers. So, if we start in Fresno, we have shrub desert, okay? And then as we continue walking, we will enter grassland, which is temperate grassland. And then as we continue, again, we're walking a straight line to Mount Whitney, right, as if we can. So desert, temperate grassland, temperate savanna, as more trees develop because of the higher precipitation. Temperate deciduous biome, as there's enough precipitation to have more deciduous trees around. Boreal forest, as the precipitation remains the same, but the temperature lowers. Taiga, as the precipitation lowers and the temperature lowers even more. And then good old tundra, where it's nice and cold. So we have gone desert, temperate grassland, temperate savanna, temperate deciduous, boreal forest, taiga, and tundra. Those are 1, 2, 3, 4, 5, 6, 7 biomes by traveling from 100 meters in elevation to a little bit over 4,000 meters in elevation, 100 kilometers from Fresno to Mount Whitney. So all that to say that, this is a guideline. This is a guideline. But as you go up or down in vertical zonation, okay, the difference in temperature and the difference in precipitation are going to be dictated by the terrain, and it's going to cause the manifestation of different biomes. Okay, so this is the temperature and precipitation of different biomes. So that's why I start out with a warning. This is not what defines a biome. What defines a biome is the life that's living in it, but the life that's living in it is defined by these two items. Okay, so what do we have? Okay, we have, in red, we have the temperature in degrees Celsius. In blue, we have the precipitation. So the higher the blue, the more rain do we have. The lower the blue, the less rain do we have. Okay. If the temperature is sufficiently high and the precipitation is sufficiently low, evaporation exceeds precipitation, you end up with dry months. If the precipitation is above the temperature, then precipitation exceeds evaporation, and you end up with wet months. If the precipitation is significantly higher than the temperature, then the scale changes and you end up with very, very wet months. Okay. Additionally, that red at the bottom means that those months on average are above freezing. So January, February, March, April, May, June, July, August, and blah, blah, blah. They're all above freezing. Over here in Philadelphia, Pennsylvania, United States, January, February, and December are below freezing. But in Brazil, it's all warm, right? So what do we have here? Here we have, it's all going to be warm temperatures. So it's all going to be nice and temperate, okay? But the winter months are going to be wet, and the summer, let's try it again. The spring, summer, and fall, there we go. The spring, summer, and fall are dry, okay? That's San Diego, California. Philadelphia, Pennsylvania, okay? The winters are going to be cold because we have at least 3 months that fall below freezing. The summers are going to be very warm, I mean, we have peaks here of 50 degrees Celsius, okay? And the precipitation is going to be about the same throughout the year. Let's look at Brazil. So Brazil, very interesting. The temperature is never going to go below freezing. As a matter of fact, it is perfectly steady at about 58 degrees Celsius. The precipitation goes from a high scale to a low scale in October, and then it goes back up. So over here we almost have deluges, and over here we just have a rainy season. So effectively, it never stops raining very much at all in Brazil. If you don't like rain, don't move to Brazil. Okay, so now we're starting with our biomes. Okay, tropical rainforest, and it amuses me that, wow, that's exciting. The the thing is covering the the wow, I hadn't seen that before. See how it's covering our little temperature precipitation? It doesn't matter. It's going to look like this. Okay. I just think it's funny that they covered it. Anyways, tropical rainforests occur where rainfall is abundant, more than abundant. See this dark blue? That's more than abundant. We're looking at, ooh, 300 millimeters or more of precipitation. That's insane. Okay, so more than 200 centimeters, 80 inches per year, and temperatures are warm to hot year round. So you can see that the temperature doesn't change. It's hot, and we're going to have 200 centimeters of rain a year. Incredible. Okay, tropical rainforest. That's one. 8 to go. Let's see. Tropical seasonal forests have annual dry seasons. Okay, so let's see. Many tropical regions are characterized by distinct wet and dry seasons. Although temperatures remain hot year-round, these areas support tropical seasonal forests, drought-tolerant forests that look brown and dormant in the dry season, but burst into vivid green during rainy months. These forests are often called dry tropical forests because they're dry much of the year. Okay, so tropical seasonal forest, and you can imagine that the biome looks kind of like this, but if you're to bring the precipitation down a notch or two, and then this would not be even, right? Because it's telling us brown and dormant and dry season. Okay. So that means that in the dry season, which usually would be here, it's going to be brown and dormant. So the precipitation would go down and the temperature would go down during the winter season. Okay, so that's tropical seasonal forest. That's number 2. Tropical savannas and grasslands. Okay, where there's too little rainfall to support forests, we find open grasslands, or grasslands with sparse tree cover, which we call savannas. Okay, so notice we still have precipitation in June, July, August. That's about it. Okay, and then there's a time there's very low precipitation, and the temperature is moderate to high. Okay, so in this case, because we have precipitation only a few months out of the year, we can't support trees. So this would be a more acute event of this tropical seasonal forest. Okay, so it's number 3, tropical savanna and grasslands. I'm trying to make sure I don't miss one. Okay, deserts are hot or cold, but always dry. Okay, so here's cold. We're looking at about 22 degrees Celsius, or it can be hot. There we are about 65 degrees Celsius, but the precipitation is always low. Do you see that? Okay, so it's a desert, and they are lying here. See how it says that anywhere goes below freezing? That's a lie. Having been prior service, I went to Fort Bliss, Texas. Fort Bliss, Texas is a desert. And you know what happens in November in a desert? It snows. Yeah. Why does that bother me? Because I thought it was a desert. So back then I packed shorts to arrive at a place that had a foot of snow there. That's baloney. So deserts are hot or cold, but always dry. I'm not even sure that that dry really is true. Okay, there's definitely precipitation in the desert, but yeah, there's only 2 temperatures in Fort Bliss: very, very hot and very, very cold. Anyways, but I digress. Which one am I at? I already missed. Okay, tropical, number 1. Tropical seasonal forest, number 2. Tropical savannas and grasslands, number 3. Deserts, number 4. Okay. Temperate grasslands have rich soils. So, as in tropical latitudes, temperate or mid-latitude grasslands occur where there's enough rain to support abundant grass, but not enough for forests. This is characterized by cold winters and warm summers. Does this ring a bell? It should. And the reason it should is because this is where we live, okay? We love temperate grasslands. This is where we farm. This is where we put our cows. This is where we put our goats. This is where we put our chickens. This is where we grow our corn. This is the so-called breadbasket of the United States, okay? Temperate grassland. So this is very important. And see, rich soils, so you can farm it. You can see what's going on here. We characterized by cold winters. See the cold winter? Warm summer. See the warm summer? Okay. The temperature is mid-latitude, which it is. It is mid-latitude. It's about 45 degrees to the equator. Okay. And you have the precipitation always be the temperature, so it's going to be nice and wet all the time. Good, great place to have a farm. 1, 2, 3, 4, 5. Timber scrublands have a summer drought. Let me see. Okay, let's keep on going to have a summer drought. Let's see. These are mixed environments that can be highly variable. They can also be rich biologically. Okay, such conditions are often described as Mediterranean scrub, or in California, chaparral. It's almost, to me, it's almost indistinguishable from desert. But just because of that doesn't mean that it's not diverse. Evergreen shrubs with small leathery leaves from dense thickets, scrub oaks, drought-resistant pines, etc. So this is number 6. Now we're going to the next one. Temperate forests can be evergreen or deciduous. So these fall into 2 categories: evergreen or deciduous. What do we have? We have evergreen because we're in the Pacific Northwest. Okay, so if you've forgotten, Pacific Northwest, we have conifers. East Coast, they have the temperate broadleaf and mixed forests. So we have conifers that have deciduous trees. Okay. So these forests are grouped by tree type. Broadleaf deciduous, which lose trees seasonally, like the maple, or evergreen, the coniferous. Okay. They grow where rainfall is plentiful in the mid latitudes. Let's see. Seasonal temperatures, average winter temperatures are below freezing. Spring and fall temperatures are mild, and summers are quite warm. Sound familiar? This is where we live. We like to live at mid latitudes. This is us. If you look at the United States and you see where these biomes are at, okay, you see where the biomes are at. There's one right there. That's California, Oregon, and Washington. Okay, and here's the other one over here. The entire beyond the Rockies, right? We have all that eastern, all those eastern states. This is where we live, mid latitudes. Mid latitudes. See, here they tell us the Tropic of Cancer. So this is about 45 degrees right here. That's the best place for us to live, and that's where we have our cities. Okay. Temperate rainforest, um, abundant precipitation. Coastal forests are known as temperate rainforests. So we have temperate rainforest, moderate temperatures, cool rainy forests, often enshrouded in fog. I have been in more temperate rainforests than I care to talk about. I don't always bring this up, but I was in the National Guard, and the National Guard loves to train in temperate rainforests. We're always in a forest that looks like this. And to be honest, it's fun. It's very nice. It's a beautiful, this beautiful, majestic scenery that you see here. That's where we play all day long. So it's wet, abundant precipitation, moderate temperatures. Okay, boreal forests lie north of the temperate zone. Okay. Dominant trees are pines, hemlock, spruce, cedar, and fir. They're found in Siberia, Canada, and western United States. Here are the boreal forests here and here. Okay, all that beautiful, all that red. Okay. What is significant about this? Well, the fact is that it's very, very cold here, so the growing season is very, very short. So if you're to take a medium-sized conifer and cut it and look at its rings, you would realize that they are very, very old. Oh, I don't know what these things are. Anyways, they're very old. The rings are very, very tight because the growing seasons are so short. And this ends up making this boreal forest wood very desirable because it's very, very, very dense wood. Unfortunately, if you cut one of those trees down, it's going to take forever to have another one the same size. So it's a resource that we kind of need to protect. Tundra, okay. Tundra is a treeless landscape. Temperatures are below freezing most of the year. So you can see down here that it's freezing almost all year except July and August. Harsh, okay. So for a long time, we used to ignore tundra. We used to think that it was there, but who cares? But as it turns out, we have learned since then that there's a lot of birds that migrate to these tundra during these 2 months, and that's where they have their offspring. Okay, because during these 2 months, the vegetation flourishes and a lot of good things happen in this tundra, and it's just a great place to have offspring because it's low in predation. Okay, and then after those 2 months, when the young ones are ready to fly, they might migrate back south. So consequently, we have found out that these tundras are actually rich resources of diversity, um, if at least through part of the year. So we don't ignore them the way that we used to. Okay, do we go through all 9 of them? Do I dare count one more time? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I counted 10. Oh well, that's pretty close. Okay, marine ecosystems. Okay, obviously we're moving from the terrestrial to wet environments, and we're addressing the fact that in every ecosystem we have trophic levels. Those trophic levels are levels of food consumption. In terrestrial environments, the base of this trophic level are photosynthetic plants like grasses. Okay, and much the same is true in marine ecosystems. Okay, most marine communities depend on photosynthetic organisms, in particular phytoplankton. Okay, so this is tiny free-floating photosynthetic algae often support a marine food web rather than trees and grasses. It is considered the base of the marine food web. This is important. Okay, um, even whales eat phytoplankton. So this is the base of many of all marine ecosystems, because at the end of the day, they are harvesting the sun's energy, and then the sun's energy is being turned into um, you know sugars and proteins, which can feed the rest of the aquatic ecosystem. Okay, in oceans, photosynthetic activity tends to be greatest near coastlines, where nitrogen, phosphorus, and other nutrients wash offshore and fertilize primary producers. Um, so this is weird. We don't, we had not realized this too long ago, but the oceans of the planet are the deserts of the aquatic waters of the aquatic biomes. So where you see blue, dark blue, there's nothing going on here. See that? Now where you see other colors like here or here, okay, what's happening is that uh, uh, um, conveyor belts, temperature and salinity conveyor belts are moving water currents rich in nutrients from one continent to another. So you can see that happening here from Russia and China to the United States, and from New England to Western Europe. And you can see it develop here at the equator as it reaches Central and Southern America, and as it goes from South America to Central Africa. Okay, so this is where these aquatic ecosystems are vibrant. Okay, and in the dark blue, those are the deserts. There's nothing going on there. Is that interesting? Okay, so we're gonna look at the oceans. We're gonna we're gonna look at oceans. We're gonna look at um, we're gonna look at lakes. We're gonna look at rivers. Okay, so we're gonna start with oceans. Okay, and as it says They can be described by depth and proximity to the shore. So you have benthic communities, which are at the bottom of the ocean. We have pelagic zones that are part of the so-called water column. In other words, based on the depth of the water column. Large predators and prey are found in the pelagic zone, okay? And I'm going to tell you why I'm saying that in a second. So you have multiple parts to the pelagic zone. You have the epipelagic zone, and that is the surface of the water where the sun and the wind causes photosynthetic organisms to thrive, okay? So epi means above, pelagic is the zone of the ocean, above the ocean. Then below that we have meso, which means the middle zone of the ocean, okay? And then below that we have the bathypelagic. Bathy means deep zone of the ocean. And then if we go beyond that, okay, let's see, we have the abyssal zone to 4,000 meters. The abyss, meaning that there's nothing there. It's empty, it's void. And then below that, below 6,000 meters, we have the hadal zone. If you don't know where that comes from Hades, hell, okay? So 6,000 meters, hadal zone. And then at the surface, the shorelines, we call that the littoral zones, okay? And then oceans have a lot of waves due to wind and due to the movement of the moon around our Earth. So we have a very important littoral zone or intertidal zone. So, as they say, a picture's worth 1,000 words. Here we go. So, epipelagic, right? So we're talking probably the first 10 to 20 meters, where sun and wind has an effect on the ocean, okay? And then we have the mesopelagic. So this is epi means above, meso means in the middle. So 10 to 20 to 1,000 meters, meso. Then we have the deep bathy. So 1,000 to 4,000 meters is the deep zone. And then 4,000 to 6,000 is the abyss, the abyssal zone. And then below 6,000, the hadal zone, or the hell zone, okay? So this is a pelagic zone, okay? Surface to 4,000. So most organisms that you and I know of and that we deal with are going to be found in the pelagic zone. So squid, tuna, sharks, whales, whatever you think about, most animals you're going to find in the pelagic zone, okay? So between the surface and 4,000 meters. And honestly, this is quite incredible, because some of the animals that like to go this far down are mammals, whales, that like to go down deep. And the reason that blows my mind is because whales have lungs. They breathe like you and I do. And it impresses me that they can go very, very, very far in the pelagic zone, compress all that air in their lungs and still be perfectly fine. But, you know, they evolved in the ocean, so they have a lot more myoglobin. They have a lot more myoglobin than you and I do. So they can pull off things that you and I can never do, but still very incredible. And then over here, we have the estuaries. Anytime you have a river, which is fresh water, run into an ocean, we call that an estuary. And that's important because there's usually a zone of very high diversity, okay? Here's a littoral or intertidal zone. So high tide to low tide, again, an area of very high diversity, which is interesting because it's a very difficult place to live. Half the time you're submerged underwater, and then half the time you're dry in the cold I cannot think of a worse place to live. What are your choices for living? Oh, I know. I would like to either be completely submerged in water or completely dried out. Fantastic. You can live in the littoral zone. As horrible as that sounds, this is a place where a lot of organisms thrive. They do very, very well in this littoral zone. So it's a zone of very high diversity. And if you don't believe me, look up the magazine Oregon Coast and take a look at some of these intertidal zones and the pictures. They are amazing. Okay. Your author wants to include this. I don't blame him. I think this is pretty cool. This is deep sea thermal vent communities. Okay. So, like, I think I've said before, we went back to the Galapagos Island and we went to the volcanic vents and we put some manned submarines down there to see what's going on. We didn't expect to find anything, and instead we find this. Okay, so what is this? This is tube worms, albino shrimp, albino crabs, albino salamanders. I mean, just a perfectly happy little ecosystem right down there in on the base of the ocean, close to temperatures that will melt steel, and you just go, wow. Evidently, life will live anywhere. And again, the reason that this is mind blowing is because until we found this, we were under the hypothesis that all life on Earth depended on the sun. But this ecosystem does not. Okay, this ecosystem depends on high energy sulfur bonds that are created in the thermal vents, and then bacteria, microorganisms, harvest this energy, and they end up being the so-called phytoplankton or first trophic level for larger and larger organisms. So all these organisms are living on high energy sulfur bonds, which is incredible. Okay, and just when you think things could not get weirder, turns out that because of the high amount of sulfur, these organisms are rich in an amino acid called cysteine, and cysteine makes the strongest bonds known in proteins. So consequently, these animals make proteins that will not degrade if you boil it. You can literally take protein from these animals, put it in a container, boil the container, and the protein would be perfectly fine. Try doing that with, I don't know, me. All my proteins are going to degrade. Okay, I don't even have to get to boiling. All I have to do is get to, ooh, that's a little bit too warm for me, and my proteins will start to unfold. But these guys, because of their high cysteine content, their proteins don't break apart. So they have evolved, they have adapted to an environment where the temperatures are super, super high, and they thrive there. Incredible. Okay, tidal shores. Okay, these are very, very important. Coral reefs are among the best known marine systems because of their extraordinary biological productivity and their diverse and beautiful organisms. So the coral reefs are the tropical rainforest of the ocean. They're also indicators. Okay, so I don't know if you've heard about coral bleaching. Okay, but coral bleaching implies that you have a beautiful coral reef and it's dying. That is scary. Why is it dying? It can be any of a number of things. It could be pollution, it could be temperature, it could be oxygen content, it could be whatever. But the point is, it's an indicator. So if you have coral bleaching going on, something bad is happening. Okay? So there's two good reasons to cry when you have coral bleaching. One is a destruction of biodiversity, and the other that it's an indicator of worse things to come. Okay, so that's something that we've been paying attention to, because anytime that a coral reef or a rainforest gets damaged, we should pay attention. Okay. Okay, mangroves. We keep on. If you're tired of mangroves, it's because they're important. They're important, and they're one of the most undervalued ecosystems out there. Okay, most developers look at mangroves and they see weeds. Okay, and then you go to a biologist and they look at a mangrove and they see life. They see a diverse ecosystem. They see um, uh, uh, the um, recapture of soil. Okay, um, it's incredible what mangroves do. Okay, so again, because of the way that they propagate, okay, they actually put a little mangrove, baby mangrove, in front of themselves, okay, with a root, and they wait until silt and soil and sand accumulates, and then once there's enough soil there to hold the mangrove, the tether disappears, and a new mangrove starts to live there, continuing to capture more soil. Okay, so this is a way of this is a way of creating soil. It's a way of creating land, um, soil reclamation. Okay, and the only organism that we know that does that, aside from ourselves, are mangroves. And then add to that the fact that these mangroves are a place where many different diverse aquatic ecosystems thrive, and where the progeny of these ecosystems live and grow to provide everything from fish to shrimp to to crabs to all these different organisms, and uh, um, the diversity involved is incredible. What else? It also inhibits the effect of weather on the coast. So mangroves are they usually have very good root systems, and they prevent damage by wind and by tides. We covered these before. We call them emergent properties. I don't know if you remember that. I also told you that it was called synergy, right? The parts, the sum of the parts is greater than the whole is greater than the sum of the parts, synergy. But that's why we keep on coming back to these mangroves, because of their diversity and all the other resources that they provide. Estuaries and salt marshes. Again, an estuary is wherever a river that is sweet water, fresh water, associates with a sea or an ocean, which is salt water. Okay, rivers empty into the sea, mixing fresh water with salt water. Um, Salt marshes, shallow wetlands, flood regularly or occasionally with seawater. And why do we care? Again, an incredible source of diversity. Um, Normally, you have organisms that uh, uh, thrive in both environments living here. Was an example. A good example would probably be a lot of the rivers in Louisiana or southern Florida, where right now people are scared to go there because you have equal probability of being eaten by a shark or a python, because you have predators from both salt water and fresh water there. They're like, really? Well, that might be terrible for us, but Mother Nature, that's Mother Nature saying this is diversity. Tidal shores, again, these are awesome in Oregon. If you have something to be proud of in Oregon, is these tidal shores. Okay. Um, what else can I tell you? There's a littoral zone is one of the harshest places to live in. Again, because these things are either submerged continuously or left to dry out. But look at the diversity. It's not incredible. Every picture from a tide pool looks, well, you know what? Let's take a look at another picture, huh? Let's look at another picture. Look at that. Anywhere you look, it's just something that's beautiful. This one, something that is very fun to do in the Oregon coast. Let's go to tide pools and see what's growing in them. Okay, and we're gonna take a little break, and I'll be right back.